Today I'm going to be talking about one thing that I believe all engineers should know. I understand that there are many different types of engineers, but for aerospace and different types of engineering, it is very important to understand electromagnetic induction. Electromagnetic induction can do many things. For instance, it replaces gravity. A lot of people believe in this gravitational force, and gravity is extremely weak. And one of the strongest currents we have on Earth is electromagnetic. Okay, it causes everything. It's everything that we see, everything that we do, our stabilization within the Earth, within reality. All of our reality is based on electromagnetic induction, electromagnetic fields within the Earth. So I'm going to be showing you that, and the videos that I have for you, I'm going to be talking about. I'll be making comments throughout the videos, so you can better understand what they are talking about. So it is very important to understand electromagnetism. A lot of people don't believe that electromagnetism could do anything with gravity, and in reality, electromagnetism should replace gravity. Gravity is a theory. Nobody really knows how gravity works, and the problem with that is they come up with a bunch of physics that don't have any relation to reality. Everything that we see, everything that happens within our lives is based on electromagnetics. And so Albert Einstein could be completely wrong, and Nikola Tesla could be completely right. And I'm going to show that to you right now. Okay, so now I'm going to be talking about gravity. I'll be going over these videos with you, and I will be leaving some comments as we go along. So let's get started with the first one.
We understand the world today in terms of four forces of nature: the strong and weak nuclear forces, electromagnetism, and gravity. Now, gravity is perhaps the most familiar, but in fact it's by far the weakest of the four forces. So weak, in fact, that we can completely ignore its effects when we explore the subatomic world.
Okay, so in the subatomic world, gravity, we can ignore it completely. And the reason why is because electromagnetism is a way heavier force than gravity. Gravity goes toward nothing. Electromagnetism is everything.
At least with today's experiments. Besides the familiar but weak force of gravity, there are three other forces in this universe, each of which is vital for our existence. Now, it may not seem obvious, but the force that holds these bubbles together is the same force that allows this flame to burn. Electromagnetism. It's the force that allows us to push and pull things, the force that allows us to see everything in the world around.
Okay, so electromagnetism is the force that we use to push and pull things. It's what makes matter, okay? This is what brings everything together. Bubbles, fire, you, me, what we see, everything. It's electromagnetism. Gravity doesn't account for nothing, okay? For all I know, gravity is a made-up theory.
And the force that allows your TV set to work. Electromagnetism is the force that holds electrons in place around the atomic nucleus and holds the atoms and molecules in place in my body. It also causes electrons to repel each other. So even though the whole planet Earth is pulling the apple down to the ground, the apple stays firmly in my hand because the electrons in its surface are repelled by the electrons in my palm. I've used the word electromagnetism to describe a single force, but electricity and magnetism seem at first sight to be very different phenomena. The magnetism that makes this top levitate seems to have nothing in common with these electrical sparks. The Greeks knew that if you rubbed a piece of amber with fur, it would pick up feathers. They also knew that certain rocks attracted iron, but they had no idea that the two were related.
Photons are the packets of energy our eyes detect to see the world around us. And in the bizarre world of quantum mechanics, photons are at the very heart of magnetism. Plunging down to the subatomic level, we can see how atoms are made up of a nucleus surrounded by a cloud of electrons.
Think about the structure of an atom. There's a positive charge to the nucleus, and then the electrons have a negative charge. These two attract each other.
To explain this attraction, quantum physicists think that both protons and electrons spit out short-lived bursts of photons. Oppositely charged particles absorb each other's light, and this draws the particles together. This attractive force is known as electromagnetism.
Atoms themselves would not hold together if it weren't for electromagnetic forces.
Electromagnetism also causes atoms to stick together, to create the molecules that form us and everything around us.
Electromagnetism is responsible for the very structure of our matter, atoms holding together.
Molecular bonds in our bodies, those are bound together by electromagnetic interactions, and therefore they're bound together by light.
A universe without electromagnetism would come apart at the seams.
If electromagnetism was turned off, matter would dissolve.
Everything would just fall apart.
Electromagnetism not only holds everything together, it makes things feel solid.
When you touch something, that's the electromagnetic force as well. We have electrons in our atoms and they repel each other, and when you try to touch something, those forces keep you from actually physically touching it.
The reason I don't fall through the floor is not that the floor is particularly solid. Most of the floor is empty space. It's the electric forces of the atoms in the floor against the electric forces of the atoms in my body that hold me up.
Okay, so gravity isn't the driving force that holds you up, it's electromagnetism. So we'll continue with that.
Just those little forces of those few atoms are enough to hold me up against the entire gravitational force of the Earth. Electromagnetism rules.
Okay, now we're going to go through and talk about electromagnetic induction. This is a very important part of engineering that people really need to understand how it works and the mechanics that are involved in it. So if you have an electromagnetic current, it actually defies gravity, and I'm going to show you that right now.
Let's switch it on, let's see what it does.
Through this coil of thick wire, we're about to pass a huge alternating electric current. On top is a 1 kilogram aluminium plate.
So we hear this noise. What's that noise?
It's the vibration of the plate, because it's vibrating at 2 times the frequency of this one.
Whoa!
Whoa! How does it do that? To find out, I've come to the place where it all started, the Royal Institution in London.
This is the key to Faraday's magnetic lab. It's amazing that lock still works.
From the 1870s onwards, it became a storeroom, which is why it survived, and it survived intact. All the joinery, giant electromagnet, exactly the same as Faraday.
So this is exactly as Faraday would have had.
That's right, yeah.
In Faraday's time, it was known that electric current creates a magnetic field, but it remained an open question whether the reverse is possible, if a magnetic field could generate electric current. Faraday answered this question with his most famous apparatus.
Faraday's electromagnetic induction ring, which is this.
In August 1831, Faraday wrapped 2 coils of insulated wire around this iron ring.
But in 1831, you could not go down to your local electrical hardware shop and ask for some meters of insulated wire. You had to insulate the wire as you went, and so as you pushed and pulled the wire out of the ring, you had to insulate it. It takes 10 working days, which is a huge investment of time.
But the investment paid off. When Faraday connected a battery to one of the coils, he saw a brief pulse of current in the other coil. And when he disconnected the battery, he saw a pulse of current in the other direction. He realized that current was induced in the second coil only when the magnetic field through it was changing. And if they hadn't been wrapped on the same ring, Faraday may have noticed that the 2 coils repel each other when the current is induced, and that's due to the interaction of their magnetic fields. Which brings us back to this. Through the bottom coil, we are passing a huge electric current, 800 amps, which alternates in direction 900 times per second. This ensures there will always be a changing magnetic field above the coil. Instead of a second coil, we're using the aluminum plate, but the principle is the same. The changing magnetic field induces currents in the plate that create an opposing magnetic field, so it levitates.
How awesome is that?
This current is not only good for levitating the plate, it can also make light bulbs glow.
A gift.
Oh, thank you. Oh, that is cool.
Not too close because it's...
Okay, so now I need to clarify a couple things. A lot of people think that they ask, how can the sun and the moon go around the flat earth and the stars? Well, everything is ran by electromagnetics, okay? So they would levitate above the earth. They don't have to be circling around the sun at all. You don't need the sun to be in the center of the universe, okay? You can easily have everything you need right here on Earth, because Earth is an electromagnetic conductor. And people do not understand engineering. They don't know how electromagnetic conductors and induction works. This will light up your lamp without plugging it in. This will heat up everything. This is exactly like the sun. So all it is ran on electromagnetic conductors, the sun and the moon, and you'll see that later on as we go along.
We'll burn the arms.
Can I put it there?
Yep.
And just as current in a toaster element heats it up, the induced current in the plate dissipates its energy as heat.
Thank you.
Yeah, to see the temperature.
Check out how hot this plate is. Oh, that is nuts. Is this your favorite demo?
It's like a flying barbecue or something.
Tell me this is not the best dinner table centerpiece. It levitates, it gives you light, and you can cook on it. And all the while, you're demonstrating Faraday's law of electromagnetic induction.
So it levitates, it's very hot, and you can cook on it, and it gives you light. So it's basically the sun. Okay, you can put electromagnetics, and it'll heat up and as a conductor. However, there are other kind of electromagnetics and magnetisms, and we'll soon go over that. So this would introduce the sun. Okay, the next one I'll be showing you will introduce the flat Earth and the moon, and how everything rotates onto the flat Earth.
Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned and we'll see you back next time.